today I'm going to go through a generalized framework that you can use in order to literally think about how the data world works, right? So when you're working with data, especially if you're not technical, you don't necessarily come from this world, there's a few things that you're generally not going to understand when you get started. And so what this is meant to be is a really high level framework to think through, okay, what does my data look like? What should it look like? What should I be considering here? This is by no means an architecture, and I do not recommend this in lieu of actually getting a hold of a data professional, because you will need someone who knows what they're doing, or else it can all get really messy really quick. But especially if you're not technical, I find that this is a really easy way to think through, how am I going to get value out of this data, and what kind of people do I need to have on board in order to actually get value out of our data. So the first thing to think about is that when you're working with data, there's 4 general actions that you're going to be taking care of. One, you're going to be actioning something on that data really quickly generally. 2, you're going to be reporting using that data. 3, you're going to be trying to predict stuff using that data. Or 4, you're going to try to prescribe something using that data. Reporting is what we're really used to in the data world. It's slapping together a dashboard, it's creating sometimes Excel or PowerPoint presentation, it's providing information back to a business stakeholder in a way that actually suits them. Prediction and prescription becomes a little bit more interesting when we start putting together like advanced algorithms to actually go, oh, since the data is saying this, what's it going to look like in the future, and putting together models that can actually help us to figure out what that prediction is going to look like. From a flavor perspective, you're generally going to be looking at 3 big things when going, oh, okay, I'm going to be actually reporting, predicting, and prescribing. The kind of data that I've got or am going to be getting, the 3 big things that you're going to be asking questions about is the speed of that data, the volume of that data, or how much it is, and the variety of that data, or how different it is, or how similar. Generally, when you're looking at speed, volume, or variety, you're going to be looking at either there's going to be a high difference in those things, or there is going to be a very low difference, right? So for example, I might have very high speed data that comes in at a low volume and comes in at a low or a high variety, right? Or I might have very low speed data, so it comes in once a day or once a week or once a month, but the volumes I get are either pretty good or the variety I get is pretty high, right? In some cases, it's really okay if none of these 3 things are true. If it's just I get very little data, I get it only once a month, and it's not very different whenever I get it. That's fantastic, and that makes it really easy to actually work with. But you're going to have either high or low in either of these 3 categories. If you've got high-speed data, you're generally going to be getting it through some kind of data stream, whether you're using some kind of event hub, or that data is just coming in all the time. This can be real time, as in it's coming in like every 1 to 2 seconds, or like as it hits, you've got it, right? Or it can be near real time, where maybe there's a 15-second delay on when you get the data. It really just depends on what you're trying to do and how you're trying to work with that data. Or it can be very low speed, in which case you're generally going to be using a batch process. Something that's going to read the data at any given point and say, hey, has this arrived? Oh, it's arrived. I need to either do an insert into this database, or I need to do an upsert into there, or I need to do something with it. But it's going to be a batch process that can run, doesn't need to run as quickly, it can run relatively slowly. When you're looking at volume, if you've got really high data volumes that are coming through, and generally high data volumes can come in very fast or very slow, depending on their speed. But if you're working with very high data volumes, there's a really good chance that you're going to be putting together a strong storage policy for how to manage that data. The reason for this is that while in most cloud instances, especially if you're using cloud storage, uploading that data can be pretty cheap, pulling it down can be pretty expensive. If you're not using cloud storage, this tends to be a little bit more mitigated, but it doesn't change the fact that you still have to have a policy for going, this is how we're going to be managing this data as it comes in. Maybe we need to keep the data available for 3 to 5 years based on the SLA that we've got with our customers. And so I am going to archive some of that data, but some of it I'm going to keep fresh and alive so that we can use it whenever we want. Or if I'm getting very low data volumes, it generally happens that sometimes there really are very few policies. And in some cases, we've seen that there are pretty much no policies as to how that data is going to be managed from a volume perspective, because there's just not enough of it that the IT team goes, oh, I really need to worry about how I'm going to get this in, or it's not moving at a velocity that they actually go, oh, I really need to worry about how I'm going to make sure to share this. So what happens in those cases is that policies that do exist tend to do with how are we going to apply governance to this data to make sure that we're keeping it safe, we're keeping it secured, we're keeping it stored. The next area you're going to look at with regards to your variety is that if there's high variety, as in the data that you're getting is very, very different all the time, you're going to be putting a lot higher degrees of automation where you go, I need to run this data through some kind of process to make it clean, to make it crispy, so that when I get it into my database or my app or wherever it is that I want to use it, the data is actually looking in the way that it should. But if there's very low variety, as in the data comes in the same every single month, all the time, in the exact same way, generally what you're going to see is you've got much more basic automation, right? Where you go, okay, just get the data, put it there. Sometimes there might not even be any automation. Somebody drops it in a folder, somebody does something to it, and that's it. In many cases, we've seen when it's very low and very basic information, there might be somebody actually in the business whose job it is to just take this file and move it over there. That happens too. It's not always the most sustainable way of doing things, but it's definitely something that we run into all the time. The last thing to think about when you're putting together this kind of framework as an actioning, reporting, predicting, or prescribing is what your team is going to look like in order to actually manage all of this. Because especially if you're trying to go, hey, I need to make a decision about, am I going to build a capability? Am I going to bring people in? Or I need to do this very specific thing on my data roadmap. The question you're going to be asking is, who needs to build this? What does that look like? What you're going to be thinking of there is your team, if you're primarily focusing on action, is going to look a lot more like software engineers. Software engineers are a heck of a lot better. They're fantastic at taking data and actioning it really quickly, right? So if you only need to do if you need to move one file from point A to point B every month, it's acceptable to have a human doing that, right? But if you're going to be trying to move 10,000 files from multiple different points orchestrated in different ways with different changes that has to happen to that, putting a human in charge of that process is generally going to mean that you're going to land in trouble at some point. When you're reporting on the data, so building Tableau dashboards, Power BI dashboards, Click dashboards, you're going to be bringing in data engineering teams. There are some more interesting things you can do by bringing in data science teams and all that stuff, but we find that for most cases, especially when you're starting off in your data journey, a data engineering team is more than enough, right? 2 or 3 guys who understand how data works, who understands how to bring it in, who understand how to manage it, who understand how to set the policies and actually drive them throughout the business, you're sorted, especially if the business is still very small and you're still wanting to limit your exposure into how much data you're actually working with. If you're looking to predict or prescribe all the time, then what you're going to be bringing in is a lot more data science, and I've put in here including machine learning. And the reason for that is with everything happening with AI and ChatGPT and all of these really cool tools that are coming out right now, people often ask, okay, cool, where does the machine learning side actually live? It generally is going to live here. Now, it does bear noting that these do work together. So for example, you're not going to have it that, you just action and therefore, you've only got software engineers and you never need to do prescriptive or prescriptive kind of analysis or anything like that. In many cases, what you might do is get, hey, I've got a team of software engineers and I'm going to leverage the skill in order to teach them some really cool machine learning stuff, and they're going to do some of that for me. It's perfectly acceptable. It happens all the time. But when you're looking to build something a little bit more complex, it's generally better to have a multidisciplinary team of software engineers, data scientists, and that also include project managers, product managers, and all of the roles that go around that in order to go, hey, this is how we actually make this work and make it work within our organization. This high-level framework tends to be a really good starting point when you're thinking about, I want to take on a few data projects, I want to create some data products for my organization. It's generally great to think about, okay, cool, what am I looking to do? I'm looking to drive some action really quickly. I'm looking to report on what's going on within a business area. I'm looking to predict what's going to happen, or I'm looking to tell my team, hey, this is what needs to happen next. right? And then to go, okay, based on this, well, what kind of data have we got? Do I have a lot of, does it come in really quickly? Well, no, not really. Okay, fantastic. Then this is what I'm going to do. Or yes, it does. So that's what I'm going to do. Does it come in at high volumes or does it come in at high variety? And how do I actually manage that? There's a whole host of stuff that happens beneath this, like looking at the quality of your data and looking at the attributes of data quality and looking at how you actually hire this team and bring it in and do a few projects so that you can actually talk to your Exco team and go, hey guys, this is what we want to do, this is where it's going to get us, and this is how it's going to look. But that's probably not going to fit in what's supposed to be a 5-minute video. If you'd like to have a chat about that, please book a call with us. I'm very happy to have a chat about how this could be applied to your business.